Hi everyone, welcome to another ALEKS tutorial. In this episode we are going to be determining the volume of base needed to titrate a given mass of acid. So in this problem it says that we have a chemistry student and they weigh out 0.142 grams of chloroacetic acid into a volume of 250 milliliters and dilutes it to the mark. So it just means that we have 250 milliliters of water and that amount of chloroacetic acid. And he plans to titrate this acid with 0.15 molarity sodium hydroxide solution. So there's a pretty simple formula for calculating this type of titration. So when we're given a concentration like this, we are going to be using the formula, the concentration of the concentration of your first item, right? Which we're going to say that M1V1, this refers to our acid. And this is going to be equal to the molarity of the second thing multiplied by the volume. And so the molarity of our second thing, we're going to make this hydroxide solution. So we have an acid and a base, and we want to calculate the volume of this sodium hydroxide solution. So that's going to be V2, right? We're going to calculate the volume that the student needs to reach equivalence point. So, first thing to do is we're given grams of this acid. We want to convert that to moles, so we're going to use molar mass. So rewrite this as H3C2 and Cl and O2. So molar mass of oxygen times 2 plus the molar mass of Cl plus the molar mass of 2 times carbon and the molar mass of 3 times hydrogen. And if we find that molar mass, we get 94.48752 grams per mole. And so now we just want to convert from grams to moles. So we are given 0.142 grams of acid. And if we multiply that by our molar mass ratio, put the grams on the bottom, 94.48752 grams of acid per every 1 mole. Grams cancel, and you're just left with 0.142 divided by that 94 value, and we are left with 0.001503. And now this is just going to be moles. Now, we're already given a volume, which is going to be V1 in this equation, the volume of our acid, and that's 250 milliliters. So 250 milliliters to liters, that's just going to be 0.250 liters. So if we divide the amount of moles of acid by the volume which this acid is in, then we get our molarity. So moles per liter is just our capital M molarity, if we divide this, we get 0.0006014, and now our units are moles per liter or just capital M. And we'll make sure we know this is M1. So this is our M1. Our V1 is just 0.25 liters, right? Which is the volume for our acid. We're given M2 as the molarity of our base solution. So we've got M1, V1, M2 is equal to 0.1500 M, and we'll just label that 2. And so if we rewrite our original equation like this, and we want to solve for V2, we can just divide both sides by M2, leaving us with our desired volume value that we want to solve for is equal to M1 times V1 divided by M2. So now we can go ahead and plug in our values. We get that V2 is equal to 0.0060114 molarity multiplied by 0.250 liters, all divided by 0.1500 molarity of our NaOH. And if you plug that into a calculator, you get 0.01002 liters, and that is the volume. Now this question wants us to calculate this in milliliters. So you actually didn't need to convert this value to liters. The reason I did it is because I usually find that to be simpler for me to avoid mistakes, just to convert things to liters. However, it's not necessary. If you plugged in 250 milliliters into this value, you could very easily just use milliliters and the units will still cancel appropriately. But I did it the long way. You can do it the short way if you like. But to convert this back to milliliters, we just obviously use our milliliters to liters fraction. Liters will cancel, and this will leave you with 10.02 milliliters. And check for sig figs. We can see that the lowest sig fig value we have is 3 sig figs for everything. So we just simplify this to 3 sig figs, and that'll give you 10.0 milliliters, and that's going to be your answer. So that means that 10 milliliters of NaOH is how much volume of this 0.15 molarity solution of NaOH you need to titrate a 250 milliliter solution containing 0.142 grams of chloroacetic acid. Alright, I hope this helped. Thanks for watching.